Hello everybody, hope you all are doing fine. This video goes over some of the very important but some basic Java concepts of classes, objects, methods, and strings. While we go through the program concepts, I will also go over some of the actual Java codes that are embedded within the lecture. I will also create other lectures with program examples and explain the programs and also bring some relevance of the concepts that we learn in this video. So let's go ahead and get started. These are some of our objectives that we are going to go over or cover. We'll look into classes, talk about their methods, talk about the methods and instance variables. We'll look into some of the get-set methods. We'll also look to see how we can call those primitive and reference variables. We'll also look into creation of objects out of the classes that we define and talk about constructors and methods. So every time we create a class, it becomes a new type, and you have seen some of the objects being created earlier when we created the input objects. I'm sure you all remember that we had created an input object out of the scanner class, and the code or the syntax that we used was scanner input, which is the name of an object, equals new scanner within parenthesis system.in, and this is exactly what we are referring to here. So here is a very simple example of a class that we are creating. I want you to pay attention to the class here. This class is a little different than what you have seen earlier. You have a class called account. It's a public, it's the access modifier, which is public. Class is the keyword for defining the account, but then inside you do not have a main method, which means this is a class that you can compile but you cannot run because I do not have a main method. So what we are trying to do over here is to define some classes which are nothing but blueprints, and from those classes we can create specific objects. Okay, so in this setup of class we are just creating the blueprint, and then once we are ready to create instances, that is when we will probably create another class which would house the main method within that test or the run or the runnable class. So in this particular class called account, I start off with a opening curly braces and a closing curly braces, and we define some variables. Now notice the access modifier over here, it's called private, which means this can only be seen within the class. Nobody else outside the class can see it. And this is an instance variable which is local within this account. Then I have a public method, and the name of the method is called setName. So anytime we define any of the private instance variable in a class, we ought to define some public methods so that we can access this instance variable. And the public methods that we would write are generally the set name and the get name. So we always say whatever the variable is, you would write a set and a get method. Those two would be public so that you can access this private string method. Okay, and I'll point some of these things out as we write some of the programs. So I would write my public set name, and this is always going to be void because just like the name suggests, setting the name, which means I do not want anything to come back to me. So set name would always use some kind of an argument, and in this case I'm trying to pass a string argument, and the string argument that I would pass is going to be associated with the instance variable. Again, it's going to be a string variable. Remember, in Java you always have to define the data type. So whatever I would get as a parameter or an argument by calling this set name is going to be set in this name. And the way I would retrieve the get name is through this public method, and again it is going to return a string value, and the name of the method is called get name, and again no parameters as such, because as the name signifies, it is supposed to get some value from you. And inside I would only have one statement saying return name. Okay, so that's a pretty standard format that you would always come across whenever we write our classes with the set get methods. What I just explained to you is all in these slides. So it has to be saved with a .java file name extension. It is going to be a class. You can compile it, but it is not going to be runnable, or you cannot run it. Okay, so class, method, and variable names, they are called identifiers. We would use camel case names. Again, those things are something that we have already done, so I'm going to fly through these things pretty quick. Uppercase letter, method, and variable names begin with a lowercase letter, and I'll point those things out to you as we go along. Instance variable, I already showed you. In our case it was the name. So an object has attributes that are implemented as instance variables and carried with it throughout its lifetime. So instance variable, generally they would exist before the methods are called. So these are some of the things that are there. Would contain methods that would manipulate the instance variable. So this is what I was referring to earlier. If I create something that is private, then you would need to have methods within the class that would allow you to interact with the instance variable. So good programming practice. This is what we was referring to again earlier, access modifiers, and those are the public and the private that you'd always see before defining a class, before defining an instance variable, or sometimes even when you're writing your methods. Okay, so public would make it available or being seen by accessible by others, whereas private would restrict that. Set name and get name. So set name method of a class account, and these are my parameters for the local variables. Again, basically what it's telling you is if we define a variable within the body of a method, then the variable can only be seen or is alive within that method. As soon as you come out of the method, that variable is not seen anymore. So that's your local variable. This is your set name. Again, I've already gone through this. And you also have your get name method. And again, whenever we do the get name, we will see that it follows a certain pattern. It will have to have a return type specified, and then within the body of the get methods, you always see a return statement. Okay, so this is the test account that I was talking about earlier. Whenever you have a class which does not have a main method, you would not be able to run them. So once you are ready to create objects, you would then create a class called account test or runnable, or testing that class, and inside that you would create the objects for testing some of those classes that you had just described. So here is this account test, and as I was mentioning earlier, this is the one that would have your public static void main, because this is what you would need to start your program. So look what we have done over here. I have imported my scanner statement, again something that you have seen earlier. Then I have my public class account test. I have a main method inside. I define an input object of the type scanner, and then this is how I would create a new object. So my account is a new object that I created out of the account class that I had defined earlier. Now in this account class, remember, we had one instance variable called name, and then we had two public methods called getName and setName. Okay, so right now I have account, new account, again no parameters, and then it says display my initial value. Now at this point, if I try to say my account dot get name, so my account is the object and get name is the method that is sitting in my account class that I had written earlier. So it should be able to extract the value from my account object. And then I'm going to say system out println enter name. Okay, so this is basically a statement asking or showing in the output device for the users, and you would use the next line method. This is just like your next int or next double method, which is associated with an input object, and this is the new string variable that I just defined in the same line. So I defined that as string the name, which is going to hold the value that I would, or the user would input that I am taking in with the method called next line. And then I would pass that value that I had stored in the name within my setName method. Remember, if you go back to your class account, this setName is created such that it would accept a string argument, and that is exactly what I'm doing here, taking the string that I had just stored and passing it within my setName method and associating that with that new object that I created called my account. And then I'm just doing a system out println, and then I'm again writing another system out printf. This time I'm actually printing out the object name that I had associated. So this is my string name in object account is. I have a new line, a string placeholder, and another new line. So initially I did not have any value. Then I came up and asked the user to input their name. The person inputted the value Jane Green, and then I went back and displayed my object back on the output screen by using the system out printf statement. Already talked about the scanner object. Next line, this is the new method that you are seeing over here. So this is a method that reads characters until a new line character is encountered. So basically, unless you hit a return, it keeps on taking all the values. So it will take a space, but as soon as you hit a return, it knows that you are at the end of the argument. And then you also have the scanner method next. So you have two methods. It's the next line that would read characters until a new line character, and then if you use the method next, then it reads the character until any white space character is encountered. So in this case, if you're using the next, as soon as you put a white space, it realizes, or it thinks that, okay, you have ended your input and would not take any more. Okay, so in this case we use the next line because remember we took this white space, so we needed to encounter this white space, and that is why we use the next line. If I would have used the next method, then it would cut off right here. So after you typed in Jane, if you put a space and try to take in green, then with the next method, this white space is not going to let you bring in the green part of it. Okay, so that's your difference: instantiating an object and a new constructor. So let's talk about this. When we talk about constructor, I would like to start by telling you all that a constructor is very, very similar to a method, but it's a special kind of a method. Okay, so if I look at the constructor, I generally would use the constructor, or if I create an object, then I would always use it with a dot notation. Okay, so when I had seen the object that I had created called my account, I would always associate any of the set or get method with that object with that dot notation, and that is exactly what this is referring to. This one is good for security purpose, and it talks about why it is not advisable to use a system out printf when you're asking the user to input some information. We always use the print line, system out print line, and then if I'm trying to display something from the program itself, I can use a system out printf, but we never use the printf to take arguments or to take values from the user. Some of the default values. So when we define our data types, be it an integer, be it a double, be it a string, sometimes they are, if I don't assign any value, they would have some basic default variables. And if when we define our string variables, null is basically our default value. Okay, so that if I do not assign any value to it, then it by default it gets null. Okay, now this is not the case when I have a integer value. By default it is 0. A double by default is 0.0. So every single data type has a default value until and unless something is assigned to it. Okay, so in this case, when we have a set name method, if I don't assign a value, by default, remember, it has null value stored inside. Okay, this is basically talking about how you can compile your Java programs, and this is important because if you may come across programs where you would define multiple classes, and remember, your classes are your blueprints, so they would not have a main method in there. So those classes that you define may be within the same project folder, and they can all be compiled with the Java command. Okay, but then you would have to write a class which would contain the main method, and that is what you can run. So in that main method, you would use, or you would create objects out of those classes that you had defined earlier. Most of the time, that class that you would use would be called some kind of a test. In that case, we saw account test. Some people I've seen, they call it the runnable. Okay, so runnable kind of tells you that that's the one that could be run, and then inside that runnable method you would have main methods, and then you can just create more and more objects inside to test to test and see if it is working okay. So let's talk a little bit about the UML, or the Unified Modeling Language program, or it's a tool that allows you to document some of these classes and objects and variables and strings within. It's a pictorial way of telling other people what your class would contain. Okay, so let's take a look at this. So anytime you define a class, you would create a UML diagram, which basically can be broken down into 3 compartments: the top, middle, and the bottom compartment. The top compartment would hold the name of the class. The middle compartment would hold the instance variables. So in this case, it's name, and look to see how it's saying a negative sign or a minus sign. This is also depicting that this is private. So this is the way you would read. Anybody who sees that diagram knows what these icons and the symbols mean. So this means the name of the class. This means there's an instance variable in the class called account. The negative sign tells you it is private, and this colon, and then we define the data type of this instance variable. Okay, the bottom compartment generally would contain methods, and the methods are set and get name, and they are public methods that are shown or depicted by this plus or the positive sign. And within parentheses, it tells you what kind of arguments it would take. So it says get name, set name, and then name is what it would set, and it's a string data type. And this one, which is get name, this one is empty, which means it does not take any parameter, but it actually would return a string when I call this get name value. Now you would see that this same UML diagram, if you have a constructor, would also include the constructor. So in reality, you can pretty much say that the top compartment would always have the name of the class. The middle compartment would always depict all the instance variables that you would have in that class, and the bottom compartment would always have all the methods that are available or used in that particular class, including constructors, which is a special kind of a method. So this is what it goes into. Return types also told you how those return types are shown in the UML diagram. The parameters, already talked about that. This is something that we have seen earlier, static main method. Okay, so it is defined as static, which indicates that the main is a static method. And basically the difference between a static and a non-static method is that in a static method, we do not need to create an object of that particular class. I can call it directly. Okay, so that's why I can call public static void main directly without having to go through creating an object out of it. Okay, import statements, this is something that we have seen earlier. So basically what this import statement is telling you is that you are importing certain APIs or certain libraries, and there is a special relationship between classes that are compiled in the same directory. Remember I was showing you earlier that you can have one project and then you can have multiple classes. So when you compile something within, it can see each other. So by default, such classes are considered to be in the same package. Okay, so they would